Thanks for providing me the opportunity to present my research work for PhenoRob here in this seminar. Stephanie, you already mentioned the title, so I think I don't have to dive into it again. Yeah, what was the scope of my dissertation or also the associated research for PhenoRob? We investigated societal acceptance, not farmers' acceptance. This is something I had frequently to explain during the start of my PhD studies of robots, AI, digitalization in agriculture, but also the innovative farming system of agrivoltaics. So why this is of importance from our point of view? So the rural idyll that is frequently portrayed, for example, in advertisements or children's literature, it does not reflect how contemporary farming systems work. So there's an idyll portrayed, but agriculture is technical. It uses technologies. Farms get bigger. And there's a divergence in public perception and how it's presented and the actual reality of farming. And this had led to controversy in the past. We have seen this, for example, with technologies, with genetic technologies or the use of GMOs, but also farming systems, for example, farm size that has been actively criticized by movements that criticized the industrialization of agriculture. And the technologies, the R&D technologies, could be part of this development to more technicized agriculture. So therefore, we developed research goals, especially identifying acceptance drivers, but also hurdles of public perceptions of R&D technologies, because those technologies have great potential to make farm systems more sustainable. And this is why it's worth researching it. First of all, it can help to enhance food security, then can help us to adopt current farming systems to the climate change impact, use inputs more sustainable, which on the other hand can help to cope negative effects of farming systems on the climate, and then of course can ensure more animal welfare. But of course there are also potential acceptance hurdles that could hinder the acceptance in the public. First of all, the perceived loss of human control. So how is it perceived when the farmer does not steer the tractor on the field anymore? Something that is really attached to emotional feelings. Data security issues, how it is perceived because those technologies gather a lot of data. And then also, what is the potential or the perceived potential to accelerate structural change in farming? And then I called it the X curses. So how is it perceived when energy generation on agricultural land has also led to controversies in the past? And how is the acceptance of innovative agrivoltaic systems, so the co-location of solar production and agricultural production on the same field, compared to open space solar system, which required the complete cessation of agricultural production on the same field. What was the study area and some important notes that should guide you through my presentation? We collected overall 3 online surveys among German residents that reflect the classical socio-demographic characteristics. Why is Germany of interest? So new food technologies have been viewed here with caution and a certain scrutiny. Our food regulations here in Germany are among the strictest in the world. And there's a certain familiarity with regulations, labeling, data protection issues, etc. So a working hypothesis might be when it's accepted in Germany, it might be accepted in other developed countries. Yes, some remarks for the research design throughout the presentation. Most of the questions were measured on a 5-point Likert scale, from 1 strongly disagree to 5 strongly agree, with a neutral midpoint at 3. So when you see a value below 3, it means more or less disagreement, and a value above 3, it means agreement with different determination sizes. And we also assessed willingness to pay more than 2 times. So this is also worth mentioned here. And this was then measured on a payment card, so measured in intervals, where participants has to choose one of the values on a payment card. I give an example here. So to the first study, 2 papers have been published from the study. First of all, the study description. So this was an online survey experiment with over 2,200 participants. The sample was split up in 4 groups in a between subject design because it was an experimental approach, and participants received positive information about crop farming robots. First of all, there was the technology description. The control group, this is why it was an experiment, just received the technology description and no further information. And then we had 3 treatment group, emphasizing on the positive potential of the technologies to enhance food security, then through greater and precise monitoring, for example, labor market effects, so the facilitation of farm work, addressing labor shortages, but enhance also the attractivity of the farm sector, and then environmental benefits. We already had this, more precise input use, save resources, for example, the potential to protect the soil and also enhance biodiversity. So we presented 3 autonomous technologies, always compared to the conventional counterpart. First of all, a fertilizer spreading drone, a not so mature technology, more projection into the future. Then the spot spraying robot, something that is also heavily researched and also developed with prototypes in PhenoRob. And then the autonomous tractor tilling the soil, always compared to the nowadays technology. So let's dive into the results of the first paper that was written about the study or has been published. The first research question was here, what influences the public perception, with special emphasis on the information provided. So we measured the acceptance as attitudes. First of all, with the direct question, should the robots you have seen before be used in farming? And then through a marketing theory, the ABC model of attitudes covering effective behavioral and cognitive components. We used, therefore, ordered logistic regression models and implemented controls to control for the treatment effects. How do the results look like? First of all, we assessed awareness towards those technologies. So first of all, the question, have you ever heard before about those technologies? And over half of the participants stated that they never heard of those technologies before. But while over half of the participants stated that they never heard about it before, 65% feel positive or very positive about the use of such technologies, while only 3% mentioned that it does not matter for them whether those technologies are used or not. So again, underlining the interest in this topic. So how do the results look like after the provision of information? This is not an ex post analysis, but between the different treatment groups. And here we can see, while all information provided statistically significant increase the attitudes toward agricultural robots, especially the environmental frame had the biggest effect. So when we then look at the second paper that we have published from the study, the research question was then here, there's not only black and white, so which nuanced opinions toward automated crop farming can we identify? Here we investigated only the control group of the first study because it was considered to be less biased while not receiving any positive information about the technology, and we used partitioning around Meteor's clustering technique and then pairwise comparison between the different treatment groups to identify statistically significant differences. And we clustered based on cluster constructs identified or built from an originally framework from Eastwood et al. That covered stakeholder opinions toward digitalization and robot use in agriculture. And we measured this or developed it for the public, for the societal perspective, and measured here different constructs, community acceptance, first of all, economic effects, environmental effects. We had this before, attracting workers. More interesting, maybe here, the lifestyle and business component. So how does it really, or how is it perceived, the effect on structural change? And then the infrastructure component. So how is it perceived regarding data vulnerability, or also should we invest in such technologies? When we then look at the results, we overall detected 4 segments that we could identify with different sizes, as you can see here: the skeptics, skeptical proponents, and enthusiasts. How did we came up with such names for the clusters? This is more or less based on the results of the clusters, the response pattern to the direct attitude question. And here you can see the enthusiasts are the enthusiasts because over 80% strongly agree that those technologies should be used in agriculture, while the proponents also over 90% are positive, but some more rather agree than strongly agree. The skeptical proponents here, 50% or almost 50% are not sure whether the technology should be used. And for the skeptics, there's also, with 48% disagreement or rather disagreement about the use detected. When we then look into how can we describe the clusters more nuanced, this was first done with social demographic characteristics. We can see that women are statistically more, that we have a higher share of women in the more skeptical clusters, and also the share of rural dwellers is higher in the more skeptical clusters. While trust was a determination as acceptance factor, as trust in farmers was statistically significant higher in the more positive groups. When we then look at selected items, we can see that especially for the skeptical clusters, but also at the proponents, we see rather not sure response pattern that those technologies could potentially foster structural change. And when we look at the environmental perspective, while it's really perceived as an advantage of the technologies for the more positive clusters, we do not see this effect, or at least the skeptics perceive that there is no contribution by the technologies for more environmental friendly farming. When we look at the second study, this is unpublished work, which is work in progress, bridging agricultural paradigms, consumer preferences for combining organic farming with technological innovation. The study description here was, or especially the research question. So we already have seen that the acceptance, the general public acceptance of R&D technologies is high in the society. But how can we set this in context? How is it compared to the well-accepted farming approach of organic farming and the less accepted technology of genetic engineering? And then in the next step, how can we find pathways for combinability, societal accepted combinability, because all of those technologies could help to ensure more environmental friendly farming. We therefore use the three-stage comparison based on construal level consumer theory with increasing psychological distance to the point of order to the consumption decision. First of all, close to consumption decision, the direct purchase decision. So how much would you be willing to pay for different milk products from organic farm cows, from genetic engineered cows, and cows farmed with R&D technologies? Then second, more distant from the consumption decision, the willingness to invest question. So participants had to spend a fictional agricultural policy budget of 50 euros to the three approaches: organic farming, genetic engineering, and R&D. And then even more far distance from the consumption decision, the policy goal assessment. So ranked the need to expand one of the three approaches compared to other European Union agricultural policy goals. As a last step, we validated our results via 4 focus group discussions. So a really complex study design here. And with the focus group discussion, we also tried to find the pathways for combining the approaches. Methods here, we used again pairwise comparison because it is a treatment experiment. I will come to this, and fraction multinomial logic models for especially identifying the effects for the willingness to invest question. So we presented to the participants as a treatment a fictional dairy farm with a crop farming sector. Again, it was an online survey framing experiments with over 2,600 participants split up in 4 groups. We had again a control that did not receive any information, but just a placebo treatment in form of knowledge questions. And then I will emphasize on the frames. So first of all, genetic engineering. Here benefits are secured yields, but it's more interesting for the cow sector. Genome edited rumen bacteria reduce methane emissions, and gene that reduces heat stress. So something that is really researched on. And risk here are perceived risk, for example, allergies and antibiotic resistances. It is not scientifically backed up, but something that is spread throughout society. For the organic farming sector, it's pretty much straightforward. Environmental benefit, less milk yield burden on the cows, but of course, reduced crop yields, leading to higher land requirements, and this in the face of a growing world population that we have to feed. And for the RAD system, we already had this precise better monitoring. Heat stress is something that we can detect among the cows, but here also emphasized on the risk of system failures because the interconnectedness of RAD systems. When we then look at the results, so first of all, the first decision stage, close to consumption, we see a pattern that is unsurprisingly, this is just a control group. So organic milk received the highest average willingness to pay, followed by milk yield or milk from cows with robot technologies and fed by robots, and then the genetically engineered cows. But when we then look at the treatment results, so how does it shift with information, we can see that especially for the treated groups, this is meant by the coral letters here, we can see that especially for the lesser accepted genetic engineering technologies, and we had this before, the less aware RAD technologies, we can see the biggest treatment effects, while for organic farming, information does not have such an effect. So here, really potential for marketing is detected. When we then look at the more far distant from consumption decision, the budget allocation, we see that the preference hierarchies remain consistent. So organic farming received on average the highest willingness to pay, followed by RAD, and then or willingness to invest, and then genetic engineering. But when we then look at the results of the fractional multinomial logit model of the average partial effects, we can see a shift in terms of treatment effects. So while it's statistically significant for all treatment groups, again, we can see that the treatment effect in favor of organic farming is here larger in terms of effect size for organic farming compared to the other two approaches. I will leave out here the policy goal assessment because the idea and the hypothesis was it is too far distance that treatment had an effect. And this was especially, or this was in particular what we have detected. So there was a perfect correlation in terms of ranking policy goals. But again, the preference hierarchies remained the same. So more interesting are the results of the focus group discussions. 3 key insights we detected 3 key insights here. First of all, participants acknowledged limited prior awareness of trade-offs for organic farming. So, for example, higher land requirements, also that the yields are significant lower was something I found astonishing, was not available knowledge for all participants. And then as a second point, the acceptance criteria differed markedly between the technologies. So RAD was widely viewed as beneficial unconditionally, while genetic engineering the acceptance was highly conditional on certain benefits, for example, animal welfare. And then when we look at the third insight, so participants emphasized that consumption changes should be considered before or alongside technology implementation. What is meant by this? So often it was before the technology implementation that participants said, yeah, technology is nice, but we should change our consumption patterns. This is particularly true, but something I see as a concern, as a big concern, because what we frequently see is called the consumer citizen gap. So participants state that they would like to consume more environmentally friendly, but in the end, when we look what people indeed shop, we can see that it does not reflect the stated preferences. When we then look into the insights on combining these sustainable approaches, we could see that despite some concerns for RAD technologies, organic farming and RAD was seen as highly welcomed as a good match. The integration of genetic engineering, unsurprisingly, was seen as more complex. Some participants even insisted genetic engineering and organic farming are two different sides of, or two different systems and should not be should not be mixed. But when synergies were perceived, labeling was frequently invoked to detect and for the consumer easily can be detected when genetic engineering was used. Then the last study, as I called it, the X-courses of agrivoltaics. This is also already published work in land use policy. Here the research question was, as stated in the beginning, does the maintenance of agricultural production, so the co-location of agricultural production and solar energy generation on the same field, lead to a higher willingness to pay for electricity compared to open space solar system? This was again an online survey with about 1,900 participants, and we presented 3 different agricultural systems. So grain production, pasture with grazing cattle, and viticulture, because the idea behind was that not only the question open space solar system and agrivoltaics does play a role in acceptance, but also the agricultural system it's implemented in. As methods, we used here contingent variation, a contingent variation study and interval regression models, and compared again between the groups with pairwise comparison and t-tests between the 2 scenarios then. How do the study design look here? First of all, we presented to the participants the pure agricultural production field. So the crop production, the pasture grazing cattle, and then the viticulture. Then we used Photoshop to implement photo montages and implement the agrivoltaic system. And as a third step in the same landscape, we also implemented the open space solar system. So now you could say, okay, it's easy, it looks much nicer, participants would decide for agrivoltaics. Yeah, this might be true just based on the pictures, but we provided first of all to the participants, because it was based on real life examples, that solar energy generation between the agrivoltaic systems differs, and also CO2 saving potentials compared to the German electricity mix, and land requirements are higher. But for the open space solar system, we can generate much more power on the same field, much more electricity, save much more CO2 compared to the electricity mix. It is not as costly as agrivoltaics, and we do not need as much land as we need for agrivoltaic systems. So based on those informations, how do the results look like? How did the results look like? This is just, first of all, a yes or no question. Would be willing to pay more. Even with the information, we can see that agrivoltaics received a higher willingness to pay more for electricity compared to open space solar system. But while it's higher, we can see that for both systems, over half of participants disagreed that they would be willing to pay more for it. The probit model then indicated that a positive association between willingness to pay for both systems in younger age, living in a city, and being interested in renewable energies. When we then look at the differences, this is now for just participants stated yes, and overall willingness to pay, because after the yes or no question, participants had to tick what they would be willing to pay. We see here that agrivoltaics in almost all categories received high willingness to pay. But what's really interesting is that, of course, pasture received in both systems the highest willingness to pay, but the differences between the systems were not as strong as we would have expected it. So this was really a surprise for us. And what can be deduced is that the agricultural system does not matter as much as we might have expected. Then when we look at the landscape perception, because this is something frequently discussed about when it's about renewable energy implementation, that it alters the landscape, we can see that agrivoltaics in almost all categories, shown by the plus signs, was perceived as better compared to the open space solar system. But when you remember the Likert scale, so a value below 3 means disagreement, we see that, while agrivoltaics is perceived more positive compared to open space solar system, most of the values are still below 3, so it also alters the landscape negative from the public perception. Just a quick recap. First of all, we looked in how does information influences the public perception of automated crop farming. Then we try to set it in the context and try to find pathways for combinability between RAD, genetic engineering, and organic farming, all sustainable or approaches to make farming more sustainable. And then we looked at the willingness to pay, the differences between agrivoltaics and open space solar systems. What's left from our research for PhenoRob? What are the contributions? First of all, we assessed the awareness levels, which are high, acceptance factors and concerns toward automatic farming. So awareness levels, of course, are low, but especially environmental benefits drive the acceptance, and which is something where the general public is really concerned about, are structural impacts of the technologies. Then we compared the acceptance of RAD in the context with organic farming and genetic engineering. And we have seen here that organic farming over different stages is preferred compared to the other approaches, but information, especially for the lesser known and less accepted technologies, has marketing potential at the point of sale. A combination is conceivable, but labeling is frequently invoked by the society. And we have seen that agrivoltaics enjoys higher acceptance despite higher costs and land requirements, more or less regardless of the agricultural system compared to the open space solar system. So some policy recommendations we deduced from our research, and I also came up in my dissertation. So effective communication is really important, also to preempt and counter negative narratives, as we have seen it, for example, with genetic engineering, but we also seen it in other technologies that may be implemented in our daily life, like automated driving. So some concerns are really unreasonable and should be replaced by positive information, or we should really put the positive information at the forefront. But others, like, for example, I will come to this, the structural impacts, we should pay special attention into it. Then every stakeholder in the food chain is responsible, but especially the farmers. Farmers' trust was always a big determinant of technology acceptance. And so farmers should actively communicate why they need the technologies and why they want to use them. And complex issues require legislative action. So we always discuss about bureaucracy, too much labeling, etc. But it was something that we have seen that is really invoked by the general society. Then structural preconditions. Here we have the point, which was really a major concern. First of all, we should invest in research. So what is the effect of technology use on the, for example, acceleration of structural change? But here we should also present opportunities at the forefront. So, for example, for smaller farms, it could be worth, when costs can come down of those technologies, to use an automated tractor, for example, to do other farm work, or have another employment, but still be able to run the farm. And agrivoltaics here also a close circle to the other research can provide here new income opportunities for small farms where land is a scarce factor, because they do not have to cess the agricultural production on the field, can use it, but have a second income source while using agrivoltaic systems. And of course, agrivoltaic systems can be farmed more effectively with robot technologies, because due to the solar panels, it will become more difficult to farm with normal machinery between the agrivoltaic systems. And then agrivoltaics merit promotion as part of the energy transition. So as said before, the general public accepts agrivoltaics more than classical open space solar systems. So we should invest in research in such technologies, and always also think about maybe implementing, or it is something that is also in place, but we should maybe foster it to subsidize, or at least think about implementing an agrivoltaic systems as an alternative to open space solar systems when solar implementation on agricultural land is planned. With this, I will come to an end. Thank you for your attention, and my new contact details are also shown here if you want to contact me. And yeah, with this, I will come to an end. Thank you very much.